So let's continue our investigation of energy, and let's look at kinetic energy. So kinetic energy, we're going to use a capital K, capital E in order to abbreviate that. And this is going to be the energy of motion. So when something's moving, we say it has kinetic energy. And now we can calculate kinetic energy with our equation. Kinetic energy equals 1/2 times mass times volume squared. And if you'll look at your reference tables provided to you, you will see kinetic energy is right here, and here is your equation. So you do not need to memorize this equation. It is on your reference table. Now, kinetic energy is going to depend on a couple of things. It is going to depend on the mass, and it's going to depend on the speed in which the object is moving. A greater mass is going to cause a greater kinetic energy, and a greater speed is also going to cause a greater kinetic energy. So let's investigate what we just talked about and see if we can't prove that mass and speed do affect kinetic energy. So I have an object with a mass of 14 kilograms and a speed of 5 meters per second. What is the average or the object's kinetic energy? So first I need to set up my triangle. I have three things here: 1/2 mass and velocity squared. So that's what's going to go on the bottom of my triangle. 1/2, because they're all being multiplied. So 1/2 times mass times volume. And so my kinetic energy goes on top here in the blank space. So what is my object's kinetic energy? So I'm going to cover up kinetic energy in my triangle. If I was looking for velocity, this is squared. If I was looking for velocity, I'd cover up that, right? If I was looking for mass, I could cover up that, okay? So I'm going to do 1/2 times my mass, which is 14 kilograms, times my velocity squared. And my velocity here is 5 meters per second. And we are going to square that. Okay, so 5 squared is 25. And then when I do 1/2 times 14 times 25, that gives me 175. And now energy is going to be measured in joules. Okay, J for joules is the unit in which we are going to measure energy. All right. So we did talk about energy being measured in joules up here. We can give it a J. Now we know what its abbreviation is. So how does the mass affect kinetic energy? So in the previous problem, if we double the mass, what happens to our kinetic energy? So again, here's my triangle, just so we have a visual. 1/2 times mass times velocity squared, where kinetic energy goes on top. So the mass in the previous problem was 14 kilograms. So if I double the mass, double 14, that means I am 28 kilograms. So the velocity in this case is going to stay the same. Its speed is 5 meters per second. So we're going to keep our 5 meters per second. So let's go ahead and let's solve for this problem. So I'm going to cover up kinetic energy. 1/2 times mass times velocity squared. Five squared is 25. So 1/2 times 28 times 25. When I plug that into my calculator, I get 350 joules. All right. In the previous problem, we double speed. So let's look at the effect of speed. All right. So in the previous problem, my mass sustained 14. I'm going to double speed. So if my speed was 5 and I double the speed, that is going to be 10 meters per second. All right. And again, 14 kilograms was the mass. That's going to remain the same. We just want to change the speed and see what happens when we double it. Okay. So my triangle is still the same here. 1/2 times mass times velocity squared. So 1/2 times a mass of 14 kilograms. And my velocity is 10 meters per second. And I'm going to square that. So 10 squared is going to be 100. And 100 times 14 times a half is 700 joules. Okay, so let's go back to our original. Our original amount of energy was 175. So let's look at these two and let's look at them compared to the original. So let's start with mass. The original was 175. My new mass is 300 and, or I'm sorry, my new energy is 350. So how did that change? What did I have to do to 175 in order to get it to 350? I had to double it, correct? 175 times 2 is 350. Okay, let's look at the effective speed. So my original was 175, we said. And when I doubled the speed, I got 700. So what happened here? What did I have to do to 175 in order to get to 700? I quadrupled the kinetic energy. So what has more effect on kinetic energy? The mass, which doubles kinetic energy, or the speed, which quadruples it? Okay. So you should see here, you definitely see that speed has a much greater effect on the kinetic energy than the mass. What I'd like for you to do, I'd like for you to pause the video and try these two practice problems. All right, a bicycle and rider with a combined mass of 110 kilograms are traveling at a speed of 8 meters per second. What is the kinetic energy of the bicycle and the rider? All right, so again, we're finding kinetic energy. 1/2 times mass times velocity squared. Times mass of 110 times a velocity of 8. Square that. So 8 squared is 64. So 1/2 times 110 times 64 is 3520 joules. Did you get that? Good job if you did. All right. This example says the kinetic energy of the bowling ball traveling at a speed of 4 meters per second is 50 joules. Find the mass of the ball. So here's mass. I'm going to cover it up. So I'm going to do kinetic energy divided by 1/2 times velocity. So kinetic energy divided by 1/2 times velocity, which is squared. So my kinetic energy is 50 joules. My speed is 4, which I square. So 4 squared is 16. 1/2 times 16 is 8. And so 50 divided by 8 is going to give me a mass of 6.25 kilograms. And there is our final answer. Now, if we were solving for velocity, because on some of your practice problems you will have to solve for velocity, because this is squared, you would have to take the square root of that number. And so we'll do some practice problems and we'll go over those during our live instruction.